All right, guys. So this is going to be in regards to lesson 10.1, graph and quadratic functions. And also going to lead into 10.2, okay? And that's transformations and quadratic functions. All right, so let's just do a quick review. Remember, a quadratic function is just when you have a variable, right? Or a function that you're trying to solve for raised to the second power. That's what makes it a quadratic, okay? Now, remember the graph of a quadratic function makes the shape of a parabola. Use a different color for that, okay? This is a parabola. It can be like that when you're solving for x because it goes across the y-axis. Notice my graph is crossing the y-axis, okay? Y is x. The green is my graph, okay? These lines going across from left to right is my x-axis, going from top to bottom, right, or north to south if you want. It's my y-axis. So because this graph is crossing the y-axis, it's in relation to x. If I had a graph going across the x-axis or being reflected across the x-axis, okay, then my graph would be in relation to y. So in this case, if I was doing this equation, right, I would be graphing, or this equation be in relation to y. All right, let's just get started. Let's do an example. Notice here I have two functions, okay? I have this function. Let me erase this really quick. I have this function, f of x is equal to x squared. Now remember, I told you, f of x is just another way of saying y, right? I plug in some value for x, I evaluate it, I get a value out for y. It's like a function, an algorithm. Those of you guys that are into computers. Okay, if I plug in 2 for x, and I square 2, then I will get 4 for my value of y, okay? And we're going to graph this function first, x squared, and I'll tell you why. So when we're doing quadratics or exponential functions, this would be like a parent function. It's like a template. That's what we start with. It's like a template, okay? Now, let's go back to our steps. Our first step when graphing quadratic functions is finding the axis of symmetry, okay? The axis of symmetry is where the graph is going to be cut in half and it's symmetrical or the same shape and size on both sides. Okay, so let's do that. So let's plug in our values. Now, if you notice here, it says to find axis of symmetry, you're going to take your b term, make it negative, and divide it by 2 times your a term, okay? Well, if you notice here, we don't have a b term. We only have an a term. Now, remember, in this function here, I labeled them. Your a term for this function is 2. Okay, I'm talking about this function right here. For this function is 2. It's our a term. Our b term is negative 12. Our c term is 16. Okay? When you're labeling your terms, a, b, and c, we're only talking about the numbers. Only the numbers, not the x, not the variable. Because notice, we're solving for x. So we're not going to include it here because we'll still have x left over. Okay? Remember what I told you. If you don't have a number in front of your x, okay? If there's no number, there's no coefficient. Okay, there's your play video games, okay, like co-op. There's no number that's been cooperated with this x, so I'm just going to put 1 there. The reason why I can put a 1 there because 1 times anything will still be the number or variable has been multiplied by. 1 times x squared is still x squared, okay? So I can multiply that by 1 and it won't affect it or change it. Okay, so let's plug that in. So our axis of symmetry for this function will be this. X, remember solve for x, x is going to be equal to negative b. Well, if you notice, we don't have a b. We don't have a b term. So I'm just going to put 0 because 0 represents nothing, right? Okay. Then I have 2 times my a term. My a term is 1. So I'm going to put 1. Well, anything divided by 0 is just 0, right? So my axis of symmetry in this case, and that means what line is going to go across the x-axis, okay? That splits my graph in half, is going to be 0. Okay, so if I draw a graph out, I'll use red. If I make a graph, okay, this is my x-axis, let's label it. It's my y-axis, okay? Remember the origin is 0. 1, 2, 3, 4, 5. Let me just label them. It's a little messy, but you get the idea. Okay, so if you notice my axes of symmetry, so where it's going to split my parabola, remember, our graph should look something like this. Anytime we graph a quadratic equation, you're going to have some type of looking parabola, okay? I'm going to have a line going right down the middle. Well, guess what? This is on the y-axis, and it crosses the x-axis, okay? Whenever you have x equals a number, it's going to be a vertical line. Okay, if it's just x equals a number, it's a vertical line. Okay, whatever that number is where your line's going to cross the x-axis. In this case, my x is 0, so I have a line crossing the x-axis at 0. Okay, if you have y equals number, it's going to be a horizontal line. Okay, so we did that. Now we're going to go to step 2. Step 2 says find the vertex, okay, of our quadratic function. Well, if you notice here, so I'll put over here step 2, find vertex. All right. Remember, your vertex has 2 coordinates, okay? It has the x coordinate and the y coordinate. We already found the x coordinate. We just found it right here. Here's our x coordinate. X equals 0, right? So I'm just going to put 0 for here. Now we got to find the y coordinate. Well, guess what? To do that, you just take what you got for your axes of symmetry. In this case, we have 0, okay? And you're going to plug it into your equation. So back up here. Remember, I'm doing this function. This is my equation, okay? X is equal to 0. So now I'm just going to substitute or replace. We can say replace my x with 0 and solve for y. Okay, let's do that. So I have f of x. Now, I'm going to set this function equal to y. F of x is still the same thing. Remember, I'm evaluating this function at some number. That's what x represents. So instead of me putting f of x, I can just replace f of x with y. So I'm going to have y equals, remember, it's x squared. Well, x is equal to 0. So I'm going to plug in 0. And it's going to be squared. Well, anything times 0 or 0 squared is just 0. Okay? So for my y term, it's going to be 0. Okay? So then we just found our vertex. Okay? My x coordinate is 0. My y coordinate is 0. So guess what? This is where my graph is going to start. Remember, the vertex is where the 2 lines of your graph meet. If I have a line going out that way and a line going out that way, notice they come together and meet right here at the vertex. In this case, my vertex 0, 0. Okay. Now, step 3 in PowerPoint lesson says find the y-intercept. Well, we're not going to worry about finding the y-intercept just yet because we need to plot some points. Remember, the y-intercept is just where your line crosses the y-axis, okay? So we're going to go to step 4, and it says use symmetry to find additional points on the graph if necessary, okay? Well, first, before we do that, we have to plot some points, okay? So we're just going to go to step 4. We'll skip step 3 because we're not going to worry about finding the x or the y-intercept. We're going to go to step 4. Now it says we're going to plot some points and then we can use symmetry to plot additional points on the other side. All right, so we're going to plot some points. So I'm going to make a little table with values. Now, when we're plotting points, we're picking points for x. We plug those points in for x, we evaluate our expression, and we get something out for y, okay? So a good rule of thumb is it's usually good to just pick some numbers that are low, like -1, 0, 1, and we'll do one more, and 2, okay? Now, I'm taking my function, in this case, f of x, so my function, y equals x squared, and all I'm doing is taking these points from my x coordinate and substitute them in for x and solving for y. Okay, so let's do -1. If I plug in -1 for x, well, -1 squared is just +1. So I know that x is equal to -1. I'm going to have a +1. So I plot my first point. Let's plot that. Okay, so I go over to my x-axis and I follow it over all the way to -1. Okay, then my y-coordinate, remember, y is equal to 1. So I have -1 for x. I have -1 right here for x. Y is equal to 1. So I go up from -1 for my x-coordinate right here up to +1 for my y-coordinate. Notice like a crosshair. Okay, it's like a map, like north, west, or southwest, or southeast. Okay, so in this case, you can think about going to the left as west, and then since my y-coordinate is positive, I'm going up north. Okay, so I go over to the west, -1 degrees to get back that way, and then I go up north 1 degrees. Okay, so I'm gonna have a point right there. Now I go for my next point. Now I'm gonna plug in 0. Okay, we're doing our next point. So I plug in 0 for x. Well, 0 squared is just 0. And look, we already had that for vertex, right? We just proved that. When x is 0, y is 0. We had that for our vertex right here. Okay, so let's go to the next one. Our next point, we're doing 1 now. I plug in 1 for x. 1 squared is equal to 1. Okay, so when x is equal to 1, y is 1. So I go over to 1 on my x-axis, remember it's +1, and then I go up 1. So I have a point right there. All right, let's do 2. Plug in 2. When x is equal to 2, I plug in 2 for x. Okay, and then I take square root. When I square root, I squared, excuse me. 2 squared is just 4. So when x is equal to 2, y, notice y in my table, is equal to 4. So then I go up to, or excuse me, I go over 2 on my x-axis. Remember, it's +2, so I'm going to go to the right. Okay, I go over to 2, so you can think about it as going to the east. And then I go up 4, so I'm going up north. So I go over 2 units to the east, and I go up 4 units north. Okay, so if that helps you think about coordinates and plotting, we're going to have 2 points. You're going to have an x and a y, right? Okay, so then I get 4. Now, here's the deal. Remember, for step 2, it says you can use symmetry to find additional points on the graph. Remember, we want to have a parabola. We want to have a shape like this, right? We want some type of shape like this for our parabola. And remember, if your a term is positive, you know that your parabola is going to open up. Well, we know that our a term is positive because we got +1. So, and look where our dots are going. They're opening up. Okay, so I'm going to go from this side, connect my dots. So start from my vertex, I connect my dots, and we'll use green. So start from my vertex, if I connect my dots, okay, I have the right side of my parabola going up that way, okay? Instead of us having to apply extra points, all you have to do is look at your axis of symmetry, okay, the line that splits your graph in half. So in this case, it's x is equal to 0. So I have a line crossing the x-axis at 0 that splits my graph in half. If you notice, from the axis of symmetry, where there's a line going across x-axis at 0, I just count. I just count over. So let's say if I want to apply the extra point on the left side of my graph. Remember, because it wants to be symmetrical. It wants to be the same distance, same length on both sides of my graph from the axis of symmetry, right? So I just go from the middle of my graph, which is the axis of symmetry, and I just count the number of spaces that I go over to my plot, okay? So for my point 2 for x, 4 for y, so I'm going to apply that 2, 4. From the axis of symmetry, I'm 2 units over, 1, 2, okay? So then apply the same point, because remember, it has to be symmetrical, so it has to be the same distance on both sides of the axis of symmetry for my graph. I just go over 2 points. So from y is equal to 4. Remember, I have a line going across here, y equal to 4. Okay, I just go 2 points over from the axis of symmetry. So I'm going from the middle, and I go 1, lines up at 1, or -1, and then 2, lines up at -2. If you notice, look, we have a line going down at +2. So if I want to make sure it's symmetrical, I should have a line where it connects my dot at -2. So then I just plot my other point there. Okay, so I have my other point there. So then now I just connect my dots. And if you notice, it's symmetrical. Now my drawing's a little crude, but if you notice, it's symmetrical. Okay, let's erase some of this so it's not so cluttered. I'll reconnect my dots. Okay, so I have my graph. Okay, and even though it's not the best looking graph, if you notice, my length and my shape is the same on both sides. Okay, same amount of distance from x-axis on the right side, have the same amount of distance from the left of from my axis of symmetry on the left side. 1, 2 spaces. Okay, same thing here. 1 space over to the right, 1 space over to the left. Okay, and we're done. We're done graphing that. Okay, now using that, we're going to graph this function. Okay, so I'm going to put this in another video. I'm going to graph this function right here. All right, so that'll be part 2.